Hi everybody, I will continue problem solving process for mechanics of materials. Today's topic is tension and compression. In the last session, we've dealt with this tension and compression related problems. And example this time in this video is like this one. In this example, at first we must understand the structure correctly. We have some strut S is assembled to gusset G. Gusset G is welded on the plate, and gusset and the base is firmly welded and one body. And this assembly is combined on the bottom by anchor bolt. 1, 2, 3, 4 anchor bolts. When you see cross section, then outside gusset is like this one. Inside strut is S is given like this one. This was empty like this one. It is assembled by pin. Okay. When you see from this side, it can be shown like this one. Okay. Like this one. Okay, first we would like to know bearing stress between pin and strut. Okay, bearing stress. Stress is what? Stress sigma equals some forces P and S, cross-sectional area. To find cross-sectional area is very important. And here to find is compression and tension. And in this one, 40-degree angle, some forces acting P. And this diameter is, when you think about a pin is like this one. When you consider this one, the diameter is like this one. This one is diameter of pin, and diameter of pin. This one is the thickness of what? Thickness of strut. Okay. The effective area is what? Diameter is multiplied by thickness. And we have 1 and 2 the external force. This one is bearing stress for between pin and strut. And next, shear stress in pin. Shear stress tau. Tau equals what? External force is divided by actually shear area. P is same, and we would like to know shear area. When you give some force, this force is acting to this pin. And when you give some force on strut, finally, if it is cut, it is destroyed, then cut area is this surface here, and here and there. The area is what? Phi d squared of 4. Then cross-sectional area is multiplied by 2. That's the shear area. Okay. Then we can find the shear stress in pin. Next, shear stress in anchor bolt. also tau. When you consider anchor bolt here, actually this force is acting like this one. When force is acting in the degree of 40, then lateral or horizontal direction, this force is actually P cosine 40 degree. This force, let's say, is F. The F is acting 4 volts, and F is divided by 4 AS, and F is P cosine 40 is divided by what? 4 cross-sectional area pi over 4 diameter bolt squared. This one is what? Cross-sectional area of anchor bolt, and we have 4 bolts, and finally you can find tau. In any case, here unit is Newton per meter squared or pound per inch squared. Shear stress as well, also Newton per meter squared, same dimension we can have. Okay, this problem is it looks a bit complicated, but when you properly understand the mechanism, then it's not so difficult to get required answer. Okay, let's move to next question. In this example, we would like to calculate shear stress and movement, horizontal movement D. Here we have some plate is firmly rigid body, almost rigid body. There's some steel plate, and under this plate we have some elastomer or some rubber. Rubber is like this one. Let's say this one is rubber. Maybe in the bridge structure, to minimize the vibration, we often use this kind of element. And we would like to know shear stress gamma. Shear stress, not gamma, tau. Shear stress tau equals what? Some acting force is divided by what? Divided by area. This area, A, B. If it is moved right this direction, then shear force is acting V, and dimension is given. That's the shear stress. When you see from this side, then it can be drawn like this one, A and gamma D and H. Of course, we assume here gamma is very small value, and G is shear modulus of elasticity. Okay. Then we can apply maybe G tau equals G gamma. And we can find some relationship between shear stress and strain. When you apply this one, tau equals V over AB equals what? G gamma. Okay, now let's focus on gamma value. Gamma is this one, this value. And we can calculate tangent gamma. If it is very small value, you can say infinitesimal. Tangent gamma equals what? Tau? Not tau. Tangent gamma equals d over h. When angle is very small, then gamma is similar to tangent gamma. Of course, it is written in radian. Then this one is gamma. Then d value. D is what? D is h gamma. Here you can calculate gamma equals what? ABG V. When you substitute this value there, D equals H ABG V. Then finally you can decide this value. H equals ABG. Okay, that's the for this example. I always say, please solve a problem by your hand, not your eyes. Thank you very much for your watching. See you next time. Bye.